So today I'm covering final exam review, the last part 4. From problems 43 to 56. So number 43, we have to write as a single logarithm. So the first one, we have to apply product quotient and power property. Since we have the 2 here, so the 2 is we're going to apply the power property first. So it's going to be log x squared minus log 5. Now use product, and here we are going to use the product because it's addition, and this is going to be quotient. So it's going to be log 3x squared over 5. So is the answer. Number 44, we're going to solve an exponential equation. So this is the equation. Now we are going to write the 64. 64 is 4 to the power 3. So we are going to look for the basis. So since I have the 4 here, I'm changing the 64 in terms of 4. And we know that 4 to the power 3 is 64. Now it's the denominator. We can bring it to the numerator by changing the sign of the power. Since we have the same base, excuse me, the powers are going to be equal. That is the equivalent property of logarithms. So now solve for x. So we get -4 equals 2x, divide by 2. So we get x equals -2. Next, number 45. Again, we're going to solve exponential equations. So the previous problem, both sides we have only one exponent and we didn't have any problem to solve. Here we have to move the 6 to the other side first. So we have to get the exponent by itself. So we get e to the -4x equal to 3. So when we were learning about solving exponential equations, in order to solve, because the x is in the power, we have to take log or log or common logarithm or natural logarithm both sides. Since the base is e here, I'm taking ln both sides. And apply the power rule for the logarithm. So then 4x come, we have to move the 4x to the front. And remember, ln e is always going to be 1. So we get -4x equals ln 3, divide by -4, and using our calculator, we can approximate the value to -0.2747. Okay. Next, number 46. Now we are going to solve logarithmic equations. So whatever the equations, either logarithmic or exponential equations, you have to get the log or the exponent by itself. So in this case, I'm going to divide both sides by 3. And here the base is 2, so make sure we have to include the base every time we write the log. So log with base 2 of 8x equals 10. Now we learned how to convert from the log to the exponential equation. So it's going to be 8x equals 2 to the power 10. I can write the 8 as 2 cubed. So divide both sides by 2 to the power 3. You can do either, it doesn't matter. I'm just trying to make it simpler. So we subtract the powers. So x to the power 7 is 128. Next, number 47. Solve. So we have the base 3 here. Both sides we have base 3. So when we have same base and we have log on both sides, however, we have to bring this one to 1 log because it's minus. We are going to apply the quotient property. So we have to write it as a single logarithm. So it is going to be x plus 1 over x minus 3. Okay, since we have log on both sides and we have the same base, we have to, these two are going to be equal, which is going to be equal to 2. I can put the 1 because we're going to solve the rational equations. So we get 1 times x plus 1 is going to be x plus 1 equal to 2 times x minus 3. Now distribute the 2. So 2x minus 6. And now we are going to solve for x. So we're getting x equal to 7. Next, number 48. Solve. Again, here we are going to, here you see only log on one side. There is no log on the other side. In this case, we have to use the exponent, property of exponent. So first, let's apply the product property to bring it down to one single logarithm. So now we are going to write as a exponential equation. What that means, we are going to write x times x plus 7 equal to 2 to the power 3. Now distribute the x. So we get 8. Bring the 8 to the side. So it's going to be 7x minus 8 equal to 0. So when we factor this, we get positive 8 and minus 3. And we have to set each one equal to 0. So x plus 8 is 0 or x minus 1 is 0. and get the x by itself. So we get x equals -8 and x equals 1. Remember, in logarithmic equation, when you get the solutions, you have to go back and substitute here. And when I put -8 in the original problem, log -8 to the base is not defined, because log of any negative number is not defined. So that means this is not our solution. The only solution is x equal to 1. So this you have to note that log of negative number is not defined. Number 49. So it says if a couple needs $14,500 for a down payment on a house, they invest the $7,250 they have at 5.8% compounded continuously. How long will it take for their money to grow? 14,500. And remember the formula, we learned this one. The compound interest is A equals E to the power RT. A is the amount which is given as 14,500. P is the investment, which is 7,250, and R is 5.8%, which means 0.058. Now we are going to find the T, so plug it in the formula. So when you plug it in the formula, you get equals 7250 to the power 0.058 times t. So we're going to find the t. So we have to get the exponent by itself first. So we're going to divide both sides by 7,250. So these two get cancelled. So this is going to be just 2. So this is an exponential equation. So we have to take ln because we have the base L, E. So we are taking ln both sides. And move the power to the front. And ln E is 1. So t is going to be ln 2 over 0.058, which is we are getting when you enter on our calculator, which is going to be 11.95 years. Okay. And number 15, it's a word problem. Again, you can read the problem. It's a radioactive substance decays according to the model A of T equals A0 and where A is the initial amount. So the first problem, if there are 20 grams present initially, that means A0 is given as 20. And then when will there be 12 grams? That means we have to find, A of T is given as 12. Now we have to find the T, so plug it in. So it's going to be 12 equals 20 times. So we're going to find the T. When is it going to be? So first divide by both sides by 12. I'm sorry. I have to move the 20 to the other side. So divide both sides by 20. We're getting rid of the 20. So we get 3, that's equals. Now it's an exponential equation, so as before, we have to use take ln both sides. And ln E is, we know that ln E is 1. So and use your calculator to get ln of 3/5 and divide by negative 0.00472 both sides. So I got t equal to 108 years. That's a long time. So the next one, part B, in how many years will 80% of the original amount remain? So the 80% of original amount, it is going to be, we have to put 0.8080. We don't know what the original amount is, so you just enter the percentage. So now divide both sides by 80 and take ln both sides. And ln is 1. So we have to divide both sides by 0. It's the same type of problem. So we get t equals, when you enter on your calculator, you got 47.3 years approximation. Okay. Next, number 51. These are from section 8.1. It's going to be pretty simple. We have to find the sequence, the terms of the sequence defined by the nth term is given as n squared plus 1. So we're going to find the first 4 terms. That means we have to plug in n equal to 1, 2, 3, and 4. So let's put 1 first. So you replace all the n by 1. So 1 squared plus 1 is 2. 8/2 is going to be 2 squared plus 1, which is going to be 5. 8/3 is 3 squared plus 1, 10. We have to find the first 4 terms, which is 17. So the terms are 2, 5, 10, and 17. These are the first 4 terms. Next sequence is, again, we have to find the first 4 terms. We have to plug in 1, 2, 3, and 4. So A1 is 2 times 1 minus 5, which is negative 3. 2 times 2 minus 5 is 1. 2 times, negative 1. And 2 times 3 minus 5 is positive 1. The last one is 2 times 4. It's going to be 3. So then the answer is negative 3, negative 1, 1, and 3. And the last 53, we are given an equals negative 2 to the power n minus 1. Again, plug in 1, 2, 3, 4. So a1 is 1 minus 1, which is 0. Anything to the power 0 is 1. A2 is negative 2 to the power 2 minus 1, which is negative 2. Negative 2 to the power 3 minus 1, which is negative 2 squared, 4. And the last one is negative 2 to the power 4 minus 1, is going to be -8. So the answers are 1. We'll circle the answer. 1, -2, 4, and -8. So the signs are going to alternate, positive and negative, positive and negative. Okay. Next, number 54, we have to evaluate the sum, which is given as sigma k equal to 1 to 4 of -3 to the power k. Oh, sorry. 3k plus 1. What that means is we have to put k equal to 1, 2, 3, and 4 and add all the answers. Okay, so I'm going to show you. So what that means is first put 1 for k and we have to add. Next we are going to put 2 for k, we are going to add 3 and add, because sigma means addition. So 2, 3, 4. So the answer is going to be 3 times 1 is 3 plus 1 plus 6 plus 1 plus 9 plus 1 plus 12 plus 1. So the answer is going to be 34. Number 55. Same thing. We have to evaluate k equal to 1 to 2, 1 to 4. It's 2 times -3 to the power k minus 1. So we have to put k equals 1, 2, 3, 4 and add all the answers. So I'm going to put -3 to the power. I'm going to put the answer here. So only the power we are going to put 1, 2, 3, 4. So it's going to be 1, 2, 3, and 4. So the answer is going to be 2 times 1 plus 2 times -3 to the power 2 minus 1 plus 2 times -3 square plus 2 times -3. So when we add, it's going to be 2 minus 6 plus 18 -54. So the answer we got is -40. Okay. And the last problem for the review is 3 to 5 of k squared. So here we're going to start from 3 because the bottom number is 3. So we have to start only from 3 and add. So it's going to be it's going to be 3 square plus 4 square plus 5 square. It's going to be 9 plus 16 plus 25. So the answer is 30. So that is the end of this review. Okay.